All right, guys, welcome to, this is the fifth PyDataTT talk featuring Taurean Dyer. And his talk is going to be about these, actually I forgot the name of it, Taurean. But I'll introduce you.
Good, thanks to have fun.
Yeah, I got the name up anyway, so I'll just say it out loud. It's how to build interactive ML web apps with RAPIDS and Plotly. So it's going to be super cool. And before we begin, I'll just read the code of conduct for today's session. So I'll be quick. Just be kind to others. Don't put down or insult anyone. It's a professional environment, and it's a harassment-free environment, free of sexist, racist, or exclusionary jokes. We just want to have a nice time, and everyone is free to contribute. So now we can begin. So let me introduce our speaker, Taurean Dyer. He is a senior program manager at NVIDIA, and he is going to be presenting on how to build interactive ML web apps with RAPIDS and Plotly. So Taurean, you can take it away.
All right. I know, I'm loving that background. By the way, I am not a co-host. Don't worry, man. No one wants to hear from me. No, this is going to be a great session. It's going to be a little bit longer than what we're used to. This is going to be hands-on a bit, and hopefully we get through, and there's going to be a lot of information. So it's okay. I'm going to try and give us just what we need to know. And then as we go forth and we start doing more explorations, it is free time to, for everyone to play, then you'll be able to, we'll have questions. Like we brought the experts today. We have both Rob from Plotly, David from Paperspace, and Rajesh from from NVIDIA, who helped architect and engineer some of what you're going to see today. And actually more than helped, he actually is chief on this now. We will, so you'll have the opportunity to ask them questions directly, and of course play with the tools and capabilities that we will be showing off today. So still cannot share. So I'm out of opening say. But it's great to have lots of fun, lots of people here. We're at 23 at the moment, which is awesome. And I'll just wait. Oh, I'm up.
Yeah, you have co-host now.
Yeah, I'm in control. All right. So today what we're going to talk about is how to build interactive ML web apps or machine learning web apps with RAPIDS and Plotly. And when I say machine learning web apps, I don't just mean like, oh, we've got a application in the background, there's some machine learning and then it comes out. I mean like machine learning driven data visualization web apps. And it was going to be a really awesome and long title, much like the abstract, but Meetup has a fun limit to what you can and can't put up. So it's not just myself talking today, we're going to have a few guest speakers as well. And let's just get to it. So today what we're going to need to do is we're going to first set up our GPU instance. You'll get and that will, we'll turn it over to one of our special guests. We're going to have a brief introduction on RAPIDS, brief, honestly will be. And then a crash course into data visualizations where we'll start to talk about where, why, and how these data-driven visualizations are going to be needing to exist and how they're built and what we plan to do with and what you can do with them. While we're there, we're going to have an introduction to Plotly with Rob, another special guest. And then finally, we're going to get into it and we're actually going to build a web app with all the cool things that you would have learned of leading up to that point. So with that being said, I'm going to turn it over to David right now of Paperspace and just, say thank you for coming and joining us. Hey, David, how are you doing today?
Hey, I'm good. Can you guys hear me?
Yeah,
okay.
I can.
Yeah.
Oh, perfect. Great. So excited to be here. Thanks, Taurean, for having us. Also, thanks to Plotly team, NVIDIA team, everybody for making this happen. So this is great. And also thanks to PyData for hosting. So I'm David. I'm from Paperspace. I'm calling in from New York City. Beautiful day today here, summer day. And we are going to help you set up a cloud notebook environment to run this demo on. So the very first thing I should say is that if you would like some free credits, we've made a team that you can run advanced GPU instances off of. So the RAPIDS framework that we're using today requires a P5000 or higher system. So just send me a chat in the DM if you can. I believe there's an option to send a DM to, you don't select everybody, but you can select David Banis from the chat menu. And just in there, you can send me your email. I'll make sure you get on the team and you get credits. And I'll do that in about 2 minutes when I stop talking. So just by way of introduction, if you don't know Paperspace, Paperspace provides simple and scalable accelerated computing infrastructure. So we have two main products. One is called Core. Core is CPU and GPU backed virtual machines. So if you have a team of remote workers or a team of designers or engineers, visual effects people, or a group of folks that need virtual machines that are GPU backed, that's the Core product. That'll do that for you. And then today we're talking about the Gradient product, which is specifically simple and scalable ML infrastructure. So Gradient has cloud notebooks, which we're using today, and also workflows. I won't get too much into workflows, but just for future reference, workflows are simple and composable machine learning pipelines that you can assemble using a YAML syntax, basically. So that comes after, the exploration phase if you're in a notebook or something like this and you're moving to production. But that's a story for another time. So we're going to be talking about notebooks today, and I will just share my screen real quick and show you around the console. So here we go. So this is the Paperspace console. The first time you'll log in, let me just delete this notebook. I created it before the session. You'll get something like this. You'll be able to select your team up here. Normally, you're going to default on your private workspace. You will have an invite if you DM me your email. I'll invite you to the PyData demo team. From here, we've loaded a bunch of credits, and we can just go ahead and create a notebook. So to create the notebook, I would select the RAPIDS container. I would give it a name, say like PyData demo, and I'll just put my name on it so I can identify it since we'll all be on the same team. From there, we'll select a GPU machine. So we are going to select a P4000. You will not be billed. The bill is going to the team. I should also mention that we have free GPU instances that are always available. Well, I should say while supplies last, without a credit card. So similar to Google Colab or a Google Kaggle product or something like that, what you're going to get is a very quick and easy to spin up cloud Jupyter Lab environment. However, the Paperspace version of it has a lot more features. We're going to give you better and faster GPUs. We're going to give you persistent storage. We're going to give you higher RAM capacities. We're giving you 30 gigs by default, whereas Colab would give you 12 gigs. We're not going to preempt your sessions, and we're going to give you a full version of Jupyter Lab. So I'm going to come down here. I'm going to set an auto shutdown of, I don't know, an hour. And in the advanced settings, we'll just come here. We're going to grab the GitHub repo that this demo is using today. And we're just going to throw it into our workspace URL. We have a container that we've loaded up with the latest version of RAPIDS running CUDA 11. And then we'll just start like that on a P4000. So depending on the day, this takes anywhere from 20 seconds to a couple minutes to spin up. So we can see down here that we have our image setting up using the container that we specified. It's pulling in the Git repo. We can see the files starting to load here. We can see our instance is starting to spin up, and we're already running. So we have just some logs I can point you to here. We have a version history in case we need to work with any save checkpoints from the past. And then now we have our notebook all loaded up. This is the Gradient IDE version of it. And today we'll be working in the Jupyter version, which is a little more fully featured for the moment. So we just click on the Jupyter, and here we're going to launch a full Jupyter Lab notebook. And inside here, we can get a terminal, we can open the notebook or anything like that. So we're off to the races. So that's it. If you'd like to get onto this team, I can provide you some credits. Just send me a message. And if you have any issues, just DM me in the chat. I'm here to help. And I hope the rest of the demo goes great. Thanks again for having me.
Awesome. Thanks again, David. We really appreciate this, and this is really awesome for you to do. So let's give a big thanks to Paperspace for enabling us as we go through what will hopefully be a fun and hands-on workshop. As we go through, I'm going to just take over screen sharing at the moment so that you can start to see. I've sent some information in the chat. So first things first, as you get your you'll find us in the chat, so don't worry about like writing any of this down or screenshotting. But basically, when you do go through your GitHub, when you do go through in the creation of your Paperspace, there was an area where you want to specify your GitHub repo, and you'll be pulling it from my NVIDIA repo, which will include all the notebooks and some of the data that we'll be using today. We'll also, Paperspace is defaulting to the RAPIDS 19 container with CUDA 11 and Python 3.7, so you shouldn't need to change that. But at some point, when you get into your container, what you would probably want to do is open up terminal and do a wget on this data. This is a 1.56 gigabyte file of cellular data, and for notebooks 2 and 3, you will be needing that data to run it. Okay. And it should be pretty easy and fun, easy to get to. All right. So let's talk about my favorite things to talk about these days, which is RAPIDS. How many of you have actually heard of RAPIDS? You can raise your hands and I can see you on the side, I hope. All right, cool. So, for those of you who haven't, RAPIDS is basically GPU accelerated PyData, a set of GPU accelerated PyData libraries that has API familiarity to lots of, normally CPU based PyData libraries such as Pandas, scikit-learn, NetworkX, Signal from SciPy. We do follow some GeoPandas with cuSpatial. And then there's other libraries that, well, there's no good analog to right now in the PyData world. So there's cuCrossFilter. And we build and pride ourselves on being one open source and part of this community, right? So we both receive contributions from other open source projects and give contributions to those projects. So things like cuCrossFilter, we've worked with Datashader and Plotly, and try to figure out how best to not just work with them, but also GPU accelerate some of their workflows, especially with Datashader itself. Now, what does this switch over get you? Well, first, it gets you a massive speed up as your data sets grow, because as we know, our data is becoming larger, it's taking longer to process. And even when it isn't taking longer to process, things like our ETL and our workflow pipelines is still, we're still having some bandwidth issues with our ETL processes, and you usually solve that by having more nodes, or going up to like anywhere from like 20, like 1 or 2 nodes, which is what we normally work with, to computers that have hundreds, like tens to hundreds of nodes. However, with a GPU, you pretty much have a supercomputer on your desk, and we take advantage of that. And now through what we do with parallelizations, you can pretty much get a minimum of 5x speed up on based on your CPU workflows to where we get ridiculous speed ups where it's orders of magnitude faster. And I'm talking, 3, 4, 5 orders of magnitude faster than a CPU. And what does that translate to? Well, it will take, what could take 3 hours could take 2 minutes with Rapids. Walmart has a great blog where it's from 2 days to 20 seconds for their ETL workflows. So, you do get those speed ups on those larger data sets, but you also get it on smaller data sets. And we're going to delve into that now, like new capabilities that really don't exist, right? So first we invite you to, as we talk about this, we'll start going into like how do you play with Rapids, and what the differences in using Rapids is like. But then also we invite you to come join us in our community. We have the ability to, you can start with, we have a great getting started page, which guides you through getting started with Docker or Conda. You can also get started with Colab and now Paperspace. So I get to update this slide, hooray. We have a community organization where you can submit workflows and notebooks and new findings or explore what other people have done. We have great blogs and tutorial example workflows, videos on YouTube, and we have a great conversation going on Slack, and we invite you to contribute back. So, how hard is it to get in and jump into Rapids? Well, it's really not that hard, especially with partners like Paperspace. You can pretty much start up a container and go. And then when you start up a container, well, if I have one of my standard workflows, how hard is it to convert it to Rapids? And it's really this easy. It's usually just a library switch. We really do try and be something very familiar, so you don't have to relearn a whole new language or API. And you are able to pretty quickly go from Pandas, Spark, Scikit-learn, NetworkX to their analogs of cuDF, GPU Spark, cuML, and cuGraph. And as long as you have a compatible GPU, you can immediately take advantage of all those benefits. I'm going to admit this person. So before I move on, because this will be the last Rapids slides, do we have any questions on Rapids itself? You can type or you can unmute.
I think you're good, Taurean.
All right, going with Greg. Yell at Greg. No, I'm kidding. So now let's talk about a little bit about data visualization. Okay, this is a little bit. Data visualization is a huge area. There are so many subsets to it, and background knowledge that you need to have to do it right. That we couldn't really, we're not going to cover it all. There may be a clinic in the future where we do cover this and really get down into it on how do you make really good data-driven visualizations for data visualizations for data-driven storytelling, but we'll just cover the basics today. So honestly and truly, there's never really been a great time where you had more than like 50 rows in an Excel spreadsheet and then thought, okay, I understand exactly what's going on here. I can hand this off. Usually we want to make a graph or some sort of visualization that we can like at a glance look at, understand the context of what's going on. And then once you understand the context of what's going on, be able to make some sort of reasonable assumption or make an insight or get a great idea of what that visualization is telling you. And we can do this in there's several different ways that you can pose this data. some of the things, like we just said, like a stock, like if you imagine it as a story, as a novel, there's many novels have very linear storylines, right? They basically set you up, they show you exactly what you want to see and need to see, and then tell you this is what's happening. And then you can look at the visualization that's going on, say, okay, I can see what they're saying, and then, you know, keep going, right? With whatever decision point you need to make. Now, there's another type of data visualization, which is kind of a choose your own adventure. I don't know if any of you remember those books, where you actually explore and discover new things as you play and interact with that visualization. In data science, we tend to do that by having, you know, doing a process, printing out something, and then saying, oh, I need to do this, and then redoing a different process, and then printing out that visualization again. And it's pretty static in that regard. And I'll show an example of that later. But one of the people who, when you're playing with this data, it's pretty open-ended on what you get. And people who do a really good job of it are the New York Times with their infographics. If you've ever played with some of their COVID infographics or their census infographics, and I'll have to find while we have our next guest talking, I'll try and find a link or two. Didn't make it in the slide. But you don't always end up at the same point. You've learned something new, and you, Rajiv, if you don't mind, just putting a few links in there, that would be amazing, and I thank you for that. But like you don't always end up at the same point of where you started. It's not linear. It's very much like almost a buffet. So what, you know, as you go forward, what are you really trying to get out of this, and what are some of the reasons why you would do it in this way? And honestly, it's because just because you have the raw data and you have the whole story doesn't mean that story is accessible to everyone else. And accessibility does matter. Okay, in most cases, people aren't going to be in their notebook, in your notebook, running through trying to get, you know, the information that you want. Or even playing with that raw data. They just want to get to the punchline, or they just want to see not the first order discoveries that you have, but second and third order discoveries that you have. And then finally, that raw data might be extremely proprietary. And today we're going to be looking at some cell data. And honestly, a lot of that is very proprietary, but you want to, if you can abstract that information out instead of handing them just the whole data set, you can still enable others to come up with insights and accurate insights of what they need to do based upon the data that you may not be able to fully share because you've been able to pre-process it and re-render it in a way that is understandable. Okay, and that's where context matters. So what we're going to do is, you know, and to that accessibility, think of this almost like data science beyond data scientists, okay? And I mean, like, you know, people who are making decisions, and we're going to go from the idea of the in-notebook visualizations in a second and show some examples, and then we're going to focus hard on the idea of these web app dashboards, which can serve data scientists, but usually don't always, and then go to some people who are helping inform the decision makers in organizations or governments or on teams, or even just, you know, other data scientists themselves, especially, and people on the business side of things, okay? So first thing we're gonna look at is something that I showed at the last TT Labs and at PyDataTT, which is the NYC data from, oh, I'm giving away stuff. Is the NYC data from NYC taxis that I showed on Visual EDA. And instead of having just this massive set of columns here that show pickup longitude and latitude, we show and we re-represent it into a form where you can, where if you plot the dots and then figure out the concentrations, you can actually create something that looks like a map of NYC. And to illustrate just how much it looks like the map of NYC, if you add the context of a map of the New York City region, here you have the data itself, and you can actually zoom in and start to see how this data actually can be represented. So this is running on a server on a Paperspace instance right now, and there's almost 1.5 million points on this chart and this chart. But you can then start to see, okay, I have the context. These actually map out to streets. And I can see which streets, where it is, and how this looks in the world. I can also start to play with this information, and by clicking in, Q-cross filter. This is using all on Q-cross filter right now. We are able to change up that data and how it's represented on the map. You can start to make selections. And one of the cool things about this notebook is you can actually export what you see. So this can help you especially in your decision making. You can do insights based on date or time of day or the day of the month, and you can start to see, well, listen, how do people move around, and how many people moved around on the 26th of just January 2016 throughout the whole day from the Bronx to the rest of New York City. And I think if I click here, oh no, I won't be able to make this bigger, but what I can do is, as we zoom in, let me not break the chart. You can zoom in and start to see and then export that sort of data snippet that you're interested in. But this is just one way that you can represent some data. This is taxi data, that's great. So let's look at how some people do represent some of their data, which is, let's look at, this is the Plotly site. These are just different ways that you can represent similar, data to help convey the story that you are trying to tell. Okay, so if you are in stocks, like before we were in taxi, and you wanted to see where people were getting picked up and dropped off on a map. However, let's assume that you wanted to look at a clinical trial. We're all pretty sensitive to COVID and aware of COVID right now. Like, what about the trials of the drugs? Well, here you can start to see, you can start to create visualizations of a mass amount of data and seeing like where and how these this trial is going. And then finally, and now we're starting to get into the web apps for dashboards kind of look and feel of it, right? Which is that, well, this isn't in Notebook anymore. This is out of a notebook. So what does that look like? So at NVIDIA, and Rajesh was key for this. We found a way and did a proof of concept on being able to integrate the speed of RAPIDS itself, right? That GPU speed, even though it's not big data, it's still a massive chunk of data, and the ability to rerun algorithms and functions at near web app speed on things that usually take from around 98 seconds, we can run them in only a few seconds. So we have a video here where we are looking at chem informatics and what that even really looks like, and how that looks like for somebody who is running who's a specialist who is using this data to explore what is going on with their embeddings from cells as they look at, for chem informatics, as they try and discover like what sorts of chemical compounds are going to be useful for future experimentation. So I'm going to restart my share. And this time I'm going to share screen with optimizing for video clips and sharing my sound. And then I'm going to play this from about 2 minutes in. Let me know if you can hear everything that's going on.
Typically for virtual screening.
Okay.
Running on powerful GPU-based hardware such as an NVIDIA DGX SuperPod, MegaMolBART is deployable within Clara Discovery and can quickly generate novel molecules for further investigation. These results, generated using AI that understands millions of molecules, increase the probability of successful downstream experiments. Let's explore the results of a virtual screen that identified hits from the Chembl database predicted to bind to 3-chymotrypsin-like protease, a SARS-CoV-2 drug target. We'll look at how NVIDIA's RAPIDS suite of software libraries can cluster molecules by similarity in just a few seconds. The molecules represented here were first featurized by calculating Morgan fingerprints, which are a binary vector representing the molecule. Next, RAPIDS was used to reduce the dimensionality of the data with PCA and UMAP. And finally, K-means was applied for cluster assignment. The UMAP projection of the Chembl compounds is shown in the plot, with colors corresponding to cluster identity. Compounds identified in the virtual screen are plotted with large diamonds. They are also shown in the table, where columns with molecular properties can be added and removed. Next, 2 hits from the SARS-CoV-2 virtual screen are selected, and MegaMolBART infers 5 compounds between them in the molecular latent space it has learned. In this table, the compounds selected from the screen are shown at the top and bottom. The 5 generated compounds are in between. These new compounds are novel AI-generated molecules which can be prioritized for further study by scientists and researchers. The Cheminformatics Search and MegaMolBART Clara Discovery modules will be available on NGC. See the links in the description for this video.
Okay. So what we're going to look at, so the key takeaways of this is that this web application that was shown here, you're going to learn today how to go from being able to take this sort of workflow and put it into this kind of display for people who aren't going to go and engage in that workflow as readily as you are, and make it easier for them to run the processes using RAPIDS to accelerate it so that it's within us in an appreciable amount of time to execute these processes and get a re-rendering of that visualization. Now, to do this, we obviously had to, we're not the only ones who are doing this. In fact, there are other companies who are out there, like the broadinstitute.org, who are using Plotly and others to show and represent data. And these are, paid resources. These are both a little bit of some free, some paid resources, and that ability to quickly be able to label or cluster or to engage with your data is something that organizations all over the world are looking for. And workflows are very customized, especially in your machine learning pipeline, and it does take time to run them. So this ability that we're going to talk about today, and we're going to deep dive into today, is something that we see more people using in the future. So with that, what I want to do is start to educate you a bit more of like, how did we even get here? And then what do we need to as concepts for building out these applications before we dive directly into the applications. So without further ado, I want to introduce Rob from Plotly and have him start to talk about like what his company does and how they enable others to create these enterprise grade dashboards really quickly.
Excellent. Thanks a lot, Taurean. I will share my screen. drag and drop everything out here. Cool. Taurean, is on my screen showing now?
Yep, I can see your screen.
Perfect. All right. So, hey, everyone. My name is Rob Calvin. Thank you very much for having me today. I'm based out of Montreal, Canada, where the Plotly head office is. And I am a Dash application developer as well as a sales engineer. So I mostly sit in the pre-sales world, answering questions about what our tech does and does not do. Then I also develop Dash applications. So I'm here today, as Taurean said, to represent Plotly, introduce the tools that we build and maintain, answer some questions, and then also, importantly, enjoy Taurean's presentation and learn about all the tools you guys are using. To quickly start off with Plotly, the company. So Plotly was founded in 2013 by a few graduates from Harvard, Stanford, and McGill. And similar to the RAPIDS mantra here, is we're very much an open core company. About 2/3 of our development goes into open source code, and then 1/3 goes into closed source proprietary software that we sell. So our open source packages currently see about 6 million monthly downloads. And then Dash on its own sees about 400 to 500 monthly downloads, meaning another 5.5 million is our charting libraries on their own. Now, the tools and the software that we build at Plotly, it's used by everyone in every industry and every vertical, from the university students and the weekend hobbyist data scientists, all the way to the Fortune 100 company data scientists building mission critical applications. So they are free to use, lots of really cool small projects, as well as production grade applications using the Plotly software. Now, for the tools that we do develop, there can be some confusion. First and foremost, the company is called Plotly, and then our most popular tool that we build is also called Plotly, and those are the Plotly graphing libraries. These graphing libraries are available in Python, R, and JavaScript, and are best known for their interactivity. So you're thinking, if you're not familiar with the Plotly libraries, you're thinking matplotlib, Seaborn, build a line chart, bar chart, that kind of thing, except for now you are able to pull out hover data and click data, and we'll be going through what these look like in a little bit more detail soon. And these Plotly charting libraries, they're built on top of D3 and meant to be an abstraction away from D3 so that a Python data scientist can still build a lovely interactive application. And these charting libraries are fully open source and actively maintained. So there's no proprietary section to the individual charting libraries that we're building. Then these charting libraries also, they're going to cover your basic bar chart, line graph, histogram type world for your BI needs. And then they're going to go far beyond that to your network graphs, to your computational fluid dynamics. Most people at Plotly are the physics PhDs who ran into some intense JavaScript and visualization issues, and that's how they got into data viz. So we do a lot of complex scientific visualization beyond just your typical BI tools. And the next thing that we build beyond the graphing libraries, the individual charts, is Dash. And this is what we're going to be talking about primarily today. Dash is a Python, R, and Julia framework for building analytical web apps that are in your data science language of choice. So Python is by far and away the most popular version of Dash, but it is also available in R and Julia if that's what you're into. It was launched in 2017, Dash for Python, and is currently, as I mentioned, seeing 500,000 downloads and is used in every industry and every level of companies and open source tech. Now, Taurean explained it very well at the start as well. The goal of Dash is to simply be the front end of your Python code. We want to enable you, the data scientist, to extract your data, write your models, and then build the front end to it so that non-coders can still interact with it. And you can do this all on your own as like the army of one without needing a back end, a front end team. So this is for you, the data scientist, to own that entire software development lifecycle. And then the goal here, or Dash, is meant to bridge the gap between the data scientist and then those within your company who are looking to interact with your work, your models, and your code, even if they're not necessarily coders themselves and they can't go in and change your notebook and rerun cells. Dash open source, we're going to be walking through that specifically with Taurean in a few minutes. So I'll leave him to go through the specific details about building a Dash open source GPU enabled app that is for visualizing whatever data you see. Beyond Dash open source, Plotly also provides Dash Enterprise, which is a suite of tools that are meant to simplify your development cycle, handle your deployment, handle your auth, and enhance your app capabilities. So the Dash Enterprise platform gets installed on your company's virtual private cloud or on-prem or on a Plotly cloud-hosted Azure instance. Realistically, wherever you have a Linux VM, Dash Enterprise can be installed on it. And then after that, it's going to empower you, the data scientist, to be that army of one, deploy or build, deploy, and then scale out your purpose-built analytical applications. Now, for any more questions, you can send me an email at robcalvin@plot.ly. But beyond that, are there any specific questions on Plotly, the company, or any of the tools that we offer before I hand it back to Taurean? There is a hand raised, but I think that's been there for a while.
And don't be shy, everyone. Like this is a great moment to have direct access to the people who build and figure out how this can work for you.
Should be all good. I'll also be monitoring the chat if there are any specific questions. Many people are typically familiar with these tools. So if you do want to ask me some questions as we go through, let me know. Happy to help out. But beyond that, I will stop sharing, Taurean. Thank you very much for having me here and looking forward to listening.
Nice. Thanks so much. Okay. Jumping back in control. So as Rob was saying, the ability to quickly create enterprise grade visualizations really empowers you, the data science, to take not just what your work, what you know in your workflows, and apply it, but then take the audience that you can share that with to another level. This is a great tool. I really enjoyed, and Plotly was very much there and extraordinarily helpful as we were proof of concepting this, and it's worked wonderfully. So returning back to just like, now that I know that I can do this, well, what are some considerations that that I need to have that are slightly different than what I normally do in my day-to-day as a data scientist? And for one, is the MVC model. So by a show of hands, how many of you have ever heard of the MVC model, the model view control philosophy of designing web apps? Actually, if you just put it in the chat, yes or no, just don't be shy. All right, so we got a lot of great yeses. So then this will be a wonderful quick review on this. So when you are building an MVC model for your web app, generally the way that you think about it is not for your web app, for your data science, your workflow. Generally, you've got your model, which is the data itself. You have your controller, which is the algorithm and the library that based on the library that you use to run that your workflow, and then your view is generally matplotlib. So for this instance, though, we're going to change it up a little bit. Your view is still going to be your data rendering capability, which is going to be Plotly, but your controller is going to be something that takes your data itself that you've just rendered from your algorithm, which would now become your model, and then pre-process it in some way that it can then be displayed on that view. Now, as you go, as you think about it and you go through it, well, there are two a decision point that you're going to have, which is, well, where does that controller pre-processing happen? Clicky, there we go. So, and that all comes down to where you want to pre-process and render, which can either be on the server side or on the client side. Now, Plotly, we'll start down on client side. Plotly, you know, what basically happens is you have your data, you pre-process it, you know, on your server. So basically you do your data forming there, and then you send your form data to the client, who then can actually take that information and render it based upon the instructions that, you know, an app like Plotly would allow, or D3, you know, especially in those D3 based environments. On the other, and that's great for when you have, you know, a few points, like, you know, anywhere for, you know, under, I think, Rob, if you correct me wrong, you can get up to 1 million if you really have the power, right? Or is it just 100,000, 500,000?
So with that one, sub 100,000 is Plotly Express. That's our simplest tool. Between 1 million and 100,000 is going to be Plotly WebGL. And then north of 1 million is when you want to use HoloViews or Data Shader, one of those more complex tools.
Yeah. So as you go up in points, you'll notice that you want to shift away from the client doing the processing, because you have both bandwidth issues, right? You're not going to want to like send several million points over the internet, over Ethernet, and think that everyone's going to have a great experience with that. So what they do, what a company called Data Shader does, and this is an example, is that the data is brought to the server, and then they do the rendering there, and then it sends out the image. It's the rendered data, and then you view it on the client. And what's kind of interesting is that I say, and packages that use it. Well, a lot of companies are using data, like Plotly and Crossfilter are using Data Shader more and more when we get to the larger larger data visualization. And I'm going to show you one of those visualizations that they have that Plotly has. Let me just pull this up. And this is called the World Cell Towers. And this is running live on their system with 41.6 million cell towers represented. And you can zoom in, and as you zoom in, it comes, you know, it re-renders that information, and it becomes smaller and smaller. And then and you can do filtering. So let's assume that we don't want any GSM, and we just want to look at, if we want to just look at GSM cell towers. And then here's what's kind of interesting, and where Plotly, you know, one of the great things I love about this notebook, at some point under, like, I think it's 4,000 on a page, you can then hover over and get information about each and every cell tower. And that happens, and that there's a seamless transition from what is server side to client side. So this is really a great example of what can happen in terms of showcasing that data, showcasing that data and taking advantage of both capabilities simultaneously and seamlessly. So I've sent you a link in the chat on this web app, and there is some GitHub code that we'll look at later. All right. So with all that done and said, does anyone have any questions? Because we're going to make it real in the next few minutes, in the next few seconds. Does anyone have any questions that they have about, like, you know, data-driven storytelling or any of the concepts that I've shown today? And I'm sure you do. We'll have time to take maybe 2 of them right now.
Seeing chat disabled on my end, but I just had a question. Is there a preferred, like, hosting provider? I'm thinking in my mind like Heroku and equivalents. Is there a preferred provider for stuff like Plotly Dash?
Yes. Well, first and foremost, the Plotly Dash Enterprise tool that we sell. Second is going to be our open source docs. We show you how to do it on Heroku. And then that is probably the simplest and best option.
Okay.
Does that make sense?
Yeah. I've tried it briefly last year with Heroku, and I mean, it seemed easy enough. I was just wondering if there were, any like cloud container providers or anything like that.
There's a very large ecosystem of Medium articles on how to deploy Dash apps in any number of different ways. So it is something that we build and sell with Dash Enterprise, but Heroku is going to be the simplest. And then if you Google deploying it to some other resource, you're going to probably find a walkthrough tutorial. But we don't provide too many guidelines on that because it's part of our enterprise offering.
Okay, cool.
Yeah.
Thanks.
Great question.
And we will be deploying Plotly right now on Paperspace, which has an interesting concept where it is a secured environment, and we'll be showing you how you can deploy Plotly on a secured environment, what you need to set up and engage with. Okay.
I had a question. So for the last time I tried Plotly, this was a while ago actually. This was Plotly JavaScript. There were some problems that I think we will have. There were problems between Plotly and like Shadow DOM. So it wasn't playing well at the time with like web components. I guess that has progressed since. So can you get the ability to do like customizations, etc.? Like if I want to embed this into an app as a web component.
Yeah. So
has that been resolved?
That has. So you can embed Dash apps, which are React applications, inside of any other web app as either a React component or a vanilla JS component. And that does require a proprietary Dash auth package that we wrote that comes with our licensed platform. And then the nice thing about that is it allows you to communicate between the two mediums, like passing through JWT tokens from host app into Dash app, or button click and host app updates Dash app. Those kinds of things are supported, but that has been solved with the enterprise package.
Ah, that's where it is. Okay.
Yeah.
All right, thanks a lot.
All right. So how many of you have gotten your Paperspace set up and you are in your instance, and the screen kind of looks like this? You can see my screen still, right? Just say yes in the chat if you're in.
Yes.
No, if you're not.
Just a quick question. Has the chat been disabled for anyone else?
No.
Yeah, it's disabled for me too.
Yes.
Yeah. That's
Let me just check on that.
Okay.
Yeah. All right. So I wonder if the co-hosts are able to, because I've only been seeing a lot of
Okay, I got it back now.
Yeah, it's good now. Thanks.
Thanks.
Yeah.
No
Awesome.
problem.
Okay, I'll be counting on it. I'm dual monitoring right now, and I'm hoping that I'll be looking at the chat more than I'll be able to look at anything else. Okay, so some of you are going to be on this page, right? And this is the gradient app of Paperspace. It's a great app. It's a lot of fun, and it makes it really easy to kind of look at, your notebooks and see what what's going on, and you can run them in from the gradient app itself. But today we're going to be going through the Jupyter, their Jupyter side of things. So what I want you to do is, with your instances started, and I hope you all have the P5000, not the 4000 that it's sometimes that can start with. But it won't matter so much in the beginning. It may matter a little bit more towards the second data set. What I want you to do is right click and say open link in new tab. And now you have the amazing, Jupyter, the amazing and familiar Jupyter front end. And what we're going to do is, before we jump into a notebook, I want you to hit new and terminal. Then type in the word bash. And that will get you into a bash prompt for your instance. And what I'm going to do is I'm going to repaste just so we don't have to go searching, the wget command for the data, for the large data set into the chat, okay? Let's see here, where's my chat?
Just a quick question, Taurean, or in general, I guess, what's the bandwidth like for the Paperspace instances? I did notice that the dataset we're about to download took about 9 minutes for me.
It took 9 minutes for you to download it?
Yeah, it did. I was just wondering if that was on my end or in general.
It's a large file. So that's why we're downloading it now. The smaller file you will have, and I accidentally pasted the thing, but it's 1.5 gigs. We may end up like testing some of their bandwidth by downloading concurrently, but over the time that we're going to spend on the first notebook, it should finish off and you will be ready to get to the second one. So I'm going to repaste this. So without the exclamation point, sometimes I do that, but yeah, it'll vary from person to person. So Rajesh was saying it took 3 to 4 minutes. Okay. And the reason why we want to do that is because since we're going to be doing it 2 more times, we don't want to download it each time, you know, and we want to make sure that it's there for us. So what you're going to do is, the first thing is you're going to click on Paperspace Tutorial 1. Now that you are downloading it in your terminal, and here you are. So welcome to the first step. And this is just the foundations of how you go from, you know, having a standard Paperspace or any, cloud service provider to getting your data set in to Plotly so that you can render that data and start to work with it. So the first thing we're going to do is we're going to install some components, right? There's some extra libraries that don't come with the RAPIDS container. We'll be doing 2 conda installs. One of them is going to get all the Dash components that's necessary, and some of the Plotly. And then the second one is going to get the thing that we really need for us to run Dash behind a secured environment, which is Jupyter Dash. And what Jupyter Dash does is that it enables you to work, it creates a reverse proxy that enables you to then access your Dash application, even though you may have like one open port throughout, okay? So this is going to take some time, and as that takes some time, I'm going to walk through some of the next steps that you'll need. So here we will be doing some imports of the libraries, and the key ones that you're going to get, at least for this, and me as QDF. CuPy, because we do want to do some array manipulation, but keep it on the GPU as much as possible. CuPy is a GPU equivalent of NumPy, if you will. It's an analog of that. Another open source project that is part of the RAPIDS, not within ourselves, like we don't build it, but it's part of what we consider the RAPIDS ecosystem, because we all work together and have great times. Then we bring in from bouquet palettes. Plotly, we start doing graph objects. We bring in the Dash stuff, and then we have Flask for our server. Here we have Jupyter Dash, and then finally we're going to have IPython display, and that's going to do something special for us, which is going to make it a little bit easier for us to work with the links at the moment within our notebooks. So I'm going to set this to run because it's just an import. One thing, and this is Paperspace specific, your application is going to be behind, if you want to share it, it's going to be behind a Paperspace firewall if you're in the private instance. So you can get your Jupyter token really easily by importing OS and then getting this environment variable. So the data that we're working with today is, or at least for this first notebook, is pre-processed. And this is our preprocessed embeddings. It's going to have some X and Y. We've done a UMAP on it, and it's X and Y that we're going to chart. And then there's some gene expressions that we're going to look at, and then their own labels. Okay. And this information is going to be about 65,000. It's going to be over 65,000 points. So as we go through, I'm just going to run the read, and this is going to happen really fast as it comes through. So what is this data really? It's basically UMAP of gene expressions from, I believe, brain cells. And we have a full version of this notebook, like in an enterprise deployment in our single cell genomics GitHub that's free for you to use and to see how you can architect it to work within a in that sort of environment, in a genomics environment. Rajesh, Rajesh has been working on this notebook for quite some time and making improvements upon it. Rajesh, I'm gonna share that link with you. Rajesh, do you have anything you'd want to say about that the series of notebooks itself?
Yeah, the one that you're seeing is a very simple version of it, but the one that is available in GitHub actually has many more features, as well as it also allows multi-GPU, a very large data set, like million plus data set, and supports, as I said, multi-GPU, and a lot more interactive. It has a lot of additional features in terms of what a genomic scientist would like to use. Yeah.
So as we go through each one of these, these are steps that this particular notebook takes. And as you can see, just off of 32 CPUs, it takes just over 15 minutes, I believe. And when you start hitting GPUs, it drops down to anywhere between 2 and 3 minutes to run. And then when you hit 1 million, it goes from 3.5 hours to just under 10 minutes itself to run, to run the notebook from end to end. So let's see where this is. Of course. Okay. So what I'm going to do is, instead of, while we wait for that to install, I'm going to go to an instance that I have where we have this all installed already. And
I think the video, because of video friendly sharing, everything is a little bit blurry.
Okay, let me reset that then. Is that better?
Yeah.
Awesome. So this is not going to be, this is while we wait for that notebook to finish running the installs. Let's run and see what this looks like. No, you do not want to do that. Kernel restart. So as we make the first thing that we want to, well, now that we've pulled in our data set, what we want to do is we want to make a controller. And there's two things that are going to be in this controller for the bare basic model. The first one is that we're going to want to have our graph be displayed. And right now we're going to call it update graph, because this is going to be the thing that as we run different algorithms in the future, it's going to update the graph itself. So, and that graph is then going to update the visualization. The second thing that we're going to do is we're going to start with this little, we'll call this like a pseudo function, which is we're calling it update UMAP. Now, in that Clara notebook that we have, it actually reruns and it reruns UMAP and Louvain, if I remember correctly, and reclusters it all within a few seconds on the selected cells that you have. So here we're going to, so you'll be filling in like your data science, your workflow components into here, and we'll attach it to objects on the screen like buttons. Now here, we're gonna start creating our view. And the first thing that we're gonna do is we are gonna import our style sheet. We like certain style sheets. This is one that we appreciate. So this is what we're gonna use this time. And you'll notice it's similar to what we've been using in some of the other Dash applications before. The second thing is we're gonna start the web app. Now the web app now you'll see that there's one commented out that says app and one that says Jupyter Dash. The commented out application is for when you're doing it on your local machine or someplace where you have like, full control of the port so that you can like direct the notebook, direct the Plotly app to go to this, to showcase on a specific port. However, we're on Jupyter Dash because we're going to do it all within the Jupyter Notebook for now, just to show this out. And this is going to create a reverse proxy off of port 80, which is the only port that is open for consumption. We'll do some style stuff. And then here, Fig is going to be our main object. And as you can see, we run update graph and we take in our data frame. And this is the QDF data frame for us that we're going to be using. We're going to print the layout just for fun, but it's not going to show up a little bit. It's not going to matter too much, but just so that you can see what the layout can look like. Now we're going to actually go into the view itself. And that's the layout of this application. For us, and for this, and this will become necessary as we get towards the end, we're going to call this whole thing site body, and everything is going to be a child of site body. And the first thing that we're going to call is dcc.graph, which is basically going to have the figure of Fig, which is the representation of the UMAP data that we have. Now we're going to, below that, we're going to have a second area where we're going to start to look at what those interactions are that you can do within Plotly. And the first one is hovering over, and we're going to see what kind of data gets shot out from there. Then we have click data, which is basically if you click on an object, what information do you get? Then we have selection data. So what happens when we do multi-selection of those objects? And then finally, we do a zoom information. So as you zoom in, like what does that, what can you glean from that? And like, how can that help you make your applications? And what can you do? What do you have available for you to use as you make your applications? And then finally, we're going to have this new button called a shutdown dash, because this will allow you to close it. And what it does is that it actually, and we'll talk about that in a second, but and this is our view here. All right, so we have this graph, 4 different sections, and then a button to close the graph out. Now, how many of you know what a callback is? Just say yes in the chat if you can, or if you can unmute and say yes, you can do that too. Yeah, love it. No one, I've gotten no no's, so like, this is good to see. So basically with the callbacks, it's, hey, this web app is event driven. So there's going to be some input events coming, and we want to make sure there's output activities happening as those events are fired. So, you'll notice that we start calling over things like input basic interactions, hover over data. This is an interaction that you have from Plotly. And then for our output, which is hover data, which we call an ID as hover data here, we then, and then under the children of hover, we return the JSON. And we do that same thing for click data, for selected data, for relay out the zoom data. And then here we come to the button, which is to site close, and we say, hey, you got clicks? All right, And then we start a process to turn off the dashboard. Finally, we have a little bit of JS that runs to enable us to get this right here, which is going to be a link. And then that link is going to allow us to just have a single place to click. So here's the layout. It didn't do a full printout, but as you can see, the Dash app, when Dash normally runs, it will give you a URL that you can click to, and that works great if you're doing it on the dash app as to run it. But if you're doing Jupyter Dash, you're going to need to have your Paperspace notebook and your Paperspace cluster ID, and this will run it and show it. But here, this little bit of JS that we have allows you to just click the notebook here, and then it loads. And here we have our Dash application. And you have your hover data, as we said. You have your click data. You have, so this is going to help with the zoom data. You can double click to get back to the main screen. And then you can lasso a whole bunch of points. And this is going to take a second, because we named a lot of them. And here's a JSON dump of all the points and the parameters that come with that point you get. So you get things like point index, curve, and the X and Y, any custom data you wanted and whatnot. Okay. Let's see where we are here. Oh no, what did I do? And this is how you know it's live, because I forgot a -Y. That didn't run. That second one didn't run. Oh, live demos, right, everyone? Okay. So what I'm going to do is kernel. You can restart safely here at this point, if this is where you got hit, and then because it's installed, you can just run conda on there and then rerun your imports. So does anyone have any questions so far? And have you been able, I realize that you will need to redo your conda install here, which shouldn't take too long. It's, as you can see, it's happening pretty fast this time. Does anyone have any questions on at least the foundations of this application here? Where'd it go? Where'd it go? Here. The ability to take your chart, your data set and pre-process it, because what's it called again? Plotly requires that Plotly needs the information formed so that it can quickly render that data, and then making sure that it gets out, and then the kinds of data that you get from your application. All right, I see no questions. So I'm going to dive into one thing that I did miss, which is when you do your application, Plotly allows you to decide whether or not to, in Fig Trace where we have add trace, it Plotly allows you to decide whether or not you're going to use CPU client-side rendering or GPU client-side rendering. And the way that it does it is that it uses the GL suffix nomenclature on there. So what you're seeing here is actually GPU accelerated, and trust me, it requires it, because if you didn't do the CPU, it would be much slower than it is rendering for us now. You can always turn this off and just do scatter and without the GL and see how that goes, but that will be up to you. All right. So without any further questions, Rajesh, are you able to start sharing?
Is my desktop visible?
Yep, you're visible and you're good to go.
Cool, thank you. So the second tutorial is actually an extension of the first one, and a lot of Plotly components are same, but the data set is a little bit different. In the first data set, it was a completely processed data set. In this particular example, we are taking a semi-processed data set. So the original input in this case was where cell, and for each count of each gene that were identified during a wet lab experiment. And okay, so the very first thing that we do is we load the data set and we take out the first 3 genes, the raw information available to us, as we just separate that out. Okay, and we call that marker gene. We want to use these 3 for some comparison later on. It could be any of the gene available to us, but we just took this here. Then what we want to do is take the gene count information and do some create cluster, like identify the clusters in the genes that are available to us. So there are 3 main steps that we're doing for clustering. For dimensionality reduction, we are using PCA. So QML has this function for PCA wherein like in a couple of seconds it will reduce performance. In our case, we have reduced it to 50. The original input had around 4,000 columns. We reduced it to 50 most important columns that are available to us. And then we try to identify the labels or the clusters in this case using k-means. Again, that's a QML has this algorithm implemented. And by the way, both of these in the latest solution, these algorithms are exposed even for multi-GPU utilization. And once we have this k-means, for visualizing the data, we want to get the UMAP of the UMAP. And then we create a data frame where we use the XY coordinates that we computed using UMAP, and we also add the k-means, which is what we will use to color code each cell, so that we can like highlight the clusters that are cluster of cells in the data set. Once we do the clustering, I think the rest of the code is simple. It's the previous notebook. We just pass it to the generate graph method that was there in the first notebook. The additional changes that you might notice in this notebook are some advanced stuff for callback methods. One such thing is the ability to okay, so in callback, particularly using dash, you can have like one element can be updated by just one callback function, right? So there is a and if you have some elements which can be updated by more than one event, then you might want to identify which element in your UI had that callback. And to do that, you can get the context from the context object, the dash context object. You can figure out which component and what event had resulted in this callback being triggered. And you can put if-else conditions or whatever control statement that you want to filter out the events that you want to entertain, and then manage the control flow of the code. Yep. So I just ran it. Okay. Another thing that is new in the UI, I think that the UI is these three scatter plot, which are used for showing the marker genes that we had filtered out in the beginning. Right? So user can still select clusters. Like if I want to I can select the, let's say, certain number of points. What we have done is we have a callback method that will filter out the cells that are there in the selected area, identify the clusters to which those cells belong, and update the bottom scatter plot. And the bottom scatter plot essentially show individual occurrence of cells, right, in that cluster. So when I selected that area, it selected those cells, and now in these plots, individual plots, we have filtered out the genes. We identify this, we identify the cells where these genes were present, and plot them based on certain properties. The y coordinate here is the cluster to which that cell belongs, and x coordinate is one of the properties that the gene has, right? And yeah, so this is just a simple enhancement of the previous tutorial, where we allow certain number of cells to be selected, and then update a callback to update the components of the page. Any questions? Cool. Yeah. Taurean, shall we move on to the notebook?
Let's take one more second and just do a time check. I know it's 3:30 at the moment. Where is everyone right now in their ability to stay on? Just as usual, put it in the chat. Okay. All right, so we still have about another half an hour. Let's go to the third one, and then we'll go into open Q&A. All right, let's keep going, and then Rajesh, I'll have a message for you after.
Just run it, and okay. So the third notebook is again the previous one is just a extension of the previous one, where we allow where we actually do recluster, right? So when you do recluster, what we essentially allow the user to select certain clusters or a group of cell, and then run the cluster function. Rest of the there are some changes to the functions just to accommodate the changes. Essentially, if you look at this callback method, I think we introduced the ability to identify which component and what type of event were triggered inside a callback. Actually, what we are using that ability to do like two functions which are very similar, but are triggered by two different components, and use that to recluster the input data. And yeah, so that's one thing new. And the other one is the ratio, right? Let me see. Okay. Right, I thought I ran. Oh. For some reason, something crashed.
Did you shut down the other kernel?
I thought so. I did a restart. Yeah.
No, on both of them. No, just shut it down completely.
Yeah, it's the same container, right? The same. Yeah, I did shut down the other one too.
There we go. There we go.
So, okay, let it go. Okay, so now in this particular version, we have this. This particular version, I can actually select a individual cluster. So technical cluster, you can see that updated in this text field. And the way to do this is every time for every point, when you are plotting a point, you have the ability to pass some custom data, and use that custom data to track which point we are clicking. So you will see that we are actually updating the index ID of the point in the data frame. So that way, when you click on it, we have this ability to trace back the point that was selected, and you can select multiple of them. And I think selecting twice will just get it. And you can recluster it. And when we do a recluster, we repeat the same clustering thing. We do a PCA. We do k-means, and then run map, and then re-render it. So this is how, from the previous one, when we selected 3 cluster, we recluster it. Now again, the dataset that was formed by filtering out those 3 cluster has been reclustered into this thing. So these are the related molecule cells based on the gene expression. And we also it also updates the markings. So these markings essentially what we want to see is how how these genes are appearing in this 30 cluster. You can notice that the second one is not that well expressed. The first one is you see that it's all over the place. Can now on the recluster data, I have selected a few more molecules cells, and then I'm reclustering them, and then they get rearranged in this manner. Yeah. I'm good. Any questions that can answer?
Okay, so via the callbacks, as you interact with the stuff, it rerunning the custom models and then updating the visualization.
I'm sorry, can you repeat the question? There was some problem. Yeah, now it's better. Yeah.
Okay, cool. So what I'm saying is, so when you click on something there, it actually rerunning the entire cluster model and then giving you the output.
Yeah, the filtered data, right? So when that part of code. So when you select, when you select molecules, select cells, we maintain that state in these two input objects, and when you click on this, one of the buttons, we pass that information. So this is the callback that gets called, and the way to control callback to call is based on the input. So in the callback function, you have something called as input. So if there is an event that happens on, and then also event you want to entertain. So based on that, you get a call, and we also are passing the state of those two buttons. The input fields. Now based on the component, based on the event and the component that has to like two buttons, right? Sorry. One of the two buttons we actually call we call a function called update scatter plot by right? And if you notice that function there, all that we do is we use that point or the cluster ID to do a filter. So we actually the data frame and pass it on to this general function, which actually does the which reclusters. Which passes this data frame to the original cluster function, which does the savings on the map, and you get the data back, and then you replot. So you go and you so if you the main graph is plotted, and we pass that back, and the function is callback. In the callback here, this is the callback, right? In the callback, we have mentioned that the output of this function is going to update the main function and the three the individual graphs. So the main graph and the three individual graphs, and that's it. So that's the update of the plotting graphs.
So if this had to be work for like in a real time setting, we have data points coming in every second or something like that, it would be, I guess, something like similar workflow in terms of the callbacks and stuff.
Yeah, and then you'd use something like coup streams or you know, any sort of to then bring in that real time data. We do have some logs if you're treating them as logs, we have clicks, which is a log accelerator, and also like allows you to work with streaming data.
Okay. All right. So basically, once you set up that callback there, you could do anything on the back end. You could rerun a whole model, anything you want.
Pretty much.
Okay, cool.
Yeah. There are other models where we based on the events, we even run some deep learning models to do some inference.
Sorry, can you say that one more time?
So there are other examples, like there are other applications in drug discovery, where based on this event, we even go do we inference some of the deep models, right?
The deep learning models.
And yeah, and all like real time. There's nothing like no lag, nothing. It's all interactive. And most of our applications so far has like we try to maintain under 5 to 10 second latency. This is right, like the scRNA, the example that Taurean has been talking about, everything is like a couple of maybe at the most 2 seconds, but there are some big applications where most of our interactive applications are affected by 5 to 10 second latency.
So for the sake of time, just so that I can quickly and quietly close out, we're not going to end the Q&A right now. Just going to pause it for a second and just finish up. Rajesh, I'm going to just take over sharing for a second. We're just going to close out with kind of like the next steps so we see y'all having some fun with. So right to here. And let me know if you see my screen. So one of the, as you see, these are the building blocks and the starting point of how we came to build the workflows that are now being productized in Clara and for both the single cell analytics and Clara discovery. You can start to, if you go to, if you go to the web page for Clara, which I'm going to show in a second, you're going to see notebooks on here. And then you click into notebooks, and then there's that Py file called visualize. And in that Py file called visualize, this is the, oops, sorry about that. This is the, industrialization that Rajesh did, so that the entire visualization capabilities lie outside of the notebook in itself. So there's a RAPIDS, there's the HLCA lung analysis visualization, and it calls that py.visualize Py file and imports it in. And you'll see that, sorry, my mouse is on the wrong screen. Let's go down, let's go down. Right here, where we just do an import.visualize, and then we call the visualization object, send over the data, and we start the visualizations, and then this is running. And as you can see, it's localhost 5000. Starts the Flask app and does what it needs to. And then when you go to visualize, it's pretty much, there's definitely more code here, but and more capabilities than what we showed you in the tutorial, but this is what we put out. and is free for everyone to kind of see. And we've gone to different labs and presented it and shown it off at different conferences, and it's gotten a great reception. So that's the first thing that, in terms of after you play with it and you start to see it, what those next steps will be. And then the second thing is, Plotly was nice enough to GitHub their World Cell Dash Tower a long time ago, not just for us. And it'd be kind of interesting with 41 million points of cell data and rows of cell data. Wouldn't it be great if you could make some contributions to that and post it back to the Rapids community? Find different ways that you can, make a workflow out of this with all the data that they have and make a Dash application. So the application itself, the GitHub itself is, and I'll post that link out, and it shows you where you can get the data itself, and everything that they did to make the Dash application. Now, this is, as I was told, a very, very interesting and large and complex application. They do pull the cell towers, and they have to use Dask, and I believe you have to use multi-GPUs for this, right, Rob? I don't know if Rob's still here.
Yes.
Right. So, this will be an interesting thing to see, like, hey, one, that seamless transition, but two, how fast can we really push this and allow for the GPU acceleration to make some interactions and reprocessing of the data happen in as close to real time as possible. So I'll be sharing those two links with you, as well as this deck. And I want to say thank you, big thanks to both David from Paperspace, Rob from Plotly, and Rajesh from NVIDIA for coming and joining me in this PyData talk. As you saw, it was very live and it was very fun, but everything that you see here is free for you all to use and to play with. And, I hope you've learned something that you can take and use in your next, data science adventures. So back to Q&A.
Thanks, Taurean, by the way. So much fun.
Thanks. Thanks for joining us. Really appreciate it, and all the kindness you did. All right, so shall we stop recording and open it up a little bit more? So some of the things that we were talking about last time were on COVID data sets, the ability to show things to the Ministry of Health. Should we stop recording at this point in time and just kind of like talk about
Yes,
something?
so I will stop here. So I guess the formal session is now over, and we could enter into the just the usual after chat. So yeah.